You're listening to Cultivation Elevated, hosted by Michael Williamson, where we discuss vertical farming and the future of cannabis and food production.
Hey, what's going on, everyone? Welcome back to Cultivation Elevated, the podcast from Pipp Horticulture, where we explore the people, technology, and ideas shaping the future of cannabis and controlled environment ag. I'm Michael Williamson, and I'm joined today by Danielle Will, product manager here at Pipp Horticulture, with a background and degree in biological engineering. Asked Danielle to be on this podcast specifically with that background because given the recent headlines with Cyclospora today, we are going to be discussing the role of CEA in food safety and mitigating contamination risk. So at the highest level, controlled environment agriculture can reduce exposure to several external contamination pathways and gives growers greater visibility and control over their production systems. However, CEA is not inherently food safe. Food safety still depends on thoughtful facility design, water quality management, validation of sanitation procedures. A really important one is employee hygiene, monitoring and documentation, and consistent operational execution. So the recent attention surrounding Cyclospora and fresh produce provides a timely reason to have this conversation. We're not here to analyze a specific recall or speculate about what may have occurred at a particular farm. Instead, we want to discuss the broader role of controlled environment ag can play in managing food safety risks. So with indoor farms and greenhouses, you can reduce exposure to several variables that are difficult to control in open field agriculture. These can include anything from flooding, runoff, wind-blown debris, uncontrolled surface water, pests, and certain forms of environmental exposure. However, the important word is control, and that's what controlled environment ag is, right? It's the first word there. It's not elimination. So an indoor farm is not automatically a food safe farm. A greenhouse, hydroponic system, environmental controller, or vertical racking system cannot compensate for poor sanitation, unsafe water, inadequate employee training, or inconsistent operational procedures. The real value of CEA is that it gives operators more opportunities to see, monitor, isolate, document, and manage risk. Danielle, before we discuss the role of CEA, can you explain a little bit about what Cyclospora is and why it's different from other bacterial pathogens that people may be more familiar with?
Sure. Thanks, Michael, for having me today to talk about this. So Cyclospora is a parasite that spreads through water that's been contaminated with human waste. When thinking about that versus other foodborne illnesses caused by bacteria like E. coli and Listeria and Salmonella, there are a couple of differences between those and Cyclospora. The former can spread person to person more easily, whereas with Cyclospora, the parasite generally needs time in the environment before it becomes infectious. So the channels of contamination are different. Another difference is that conventional produce washes, chlorine-based or home washing just with water, are not considered effective against Cyclospora. So for producers, the strongest strategy here is prevention, protecting water sources by maintaining sanitary facilities, supporting employee hygiene, and essentially stop human waste from entering the production environment.
That's an important clarification because this should not be reduced to a conversation about washing produce more aggressively after harvest. We're used to, for me, it was interesting to learn more about parasites because this is a parasite. It's a single cell protozoan parasite, which is a lot different than some of the diseases and bacteria that we work with in other crops. And I'm more on the cannabis side. I know you're a bit more on the leafy green side. So for me, it was really interesting to learn more about the nuanced differences between those three. And this is a more complex organism as well. And as you said, it needs like a maturation time outside of its host.
Which makes tracking back where the contamination happened more difficult.
Absolutely. Because once the contamination reaches a crop or connected production system, the response becomes considerably more difficult. Prevention has to begin with people, water, infrastructure, and operational practices surrounding that crop. It's also important to clarify that wildlife is not considered a direct source of human cyclospora. Wildlife exclusion still matters for controlling other pathogens and protecting crops and water systems, but Cyclospora specifically has a human host. From an operational standpoint, one of the strongest potential advantages of CEA is physical and procedural separation from external environmental variables. One of the examples I like to give when I talk about that, because even on the cannabis side, sometimes people go, well, is outdoor cultivation better than greenhouse cultivation and indoor? And better is subjective. But when we look at something like this that can actually be measured in terms of CFUs or coliforms or anything like that nature that you can actually lab test in terms of contaminants. I use the analogy of, have you ever left your car outside and not washed it for 9 or 12 weeks? It usually has all kinds of stuff on there. It's like that layer of grime, and then there's usually some leftovers from the birds and everything else. So, and I think it's why, at least in cannabis, a lot of the outdoor crops typically go to extraction. But so, what are these different environmental external variables? Let's drill into them a little bit. So, an indoor farm or a greenhouse can reduce direct exposure to things like flooding, neighboring agricultural runoff, windblown debris, uncontrolled surface water, wildlife intrusion, and changing field conditions. CEA can also give operators greater control over who enters the production area and how they enter it, which materials enter the facility, how they're quarantined before actually getting to plants, how water is delivered and treated, how crops are separated from waste handling activities. We talk a lot about like creating spaces that the plant cycles from like a clean to dirty space as it matures, how equipment is cleaned, how environmental and production data are documented, and how quickly operators can respond to a deviation. So, however, enclosing the crop doesn't not eliminate exposure pathways, but it does give you like stage gates where you can monitor it and be more proactive and identify a problem before it becomes a real problem. So, water can still become contaminated in indoor CEA. Employees can still introduce microorganisms. Pests can still enter the building, depending on your designs and layouts. Growing media can become contaminated during manufacturing or storage or transportation or handling. Drains, air intakes, utility penetrations, loading area, tools. So sometimes people think about, oh, it's grown indoors, it's really clean. Well, look at all those different factors that can become contaminated. So I view CEA as a platform for improving risk visibility and risk management. Whether that increases control results and safer production really depends on the operator and that facility design. Danielle, is there sometimes like an assumption that soilless or hydroponic cultivation eliminates microbial risk? How accurate is that?
It is not accurate to say that it eliminates microbial risk. Soilless production via hydroponics in CEA changes the risk profile, but it does not eliminate the risk. Removing the field soil may reduce exposure to some of those hazards that you mentioned, flooding from storms, runoff from adjacent fields, animal activity, but the microorganisms can still enter the production system in CEA through the growing media, the source water, employees and tools. We often try to reuse and just clean on site a lot of the containers, such as rafts. So I would say the primary advantage of soilless production is not sterility. We're not expecting any of these things to really be sterile throughout the grow system. The advantage is visibility and control. As you said, being able to monitor and control these things is the advantage.
And I think that distinction is important both from a cultivation and facility design perspective. Removing field soil doesn't mean that we've removed biology from the production system. Crops themselves are biological systems, and CEA facility contains water, nutrients, organic material, people, equipment, and continuously wetted surfaces. So every reusable component should be evaluated as part of the food safety system. A component may perform very well horticulturally, but still creates sanitation challenges if it traps crop debris, retains standing water, contains inaccessible seams, and cannot effectively and be inspected and cleaned. And that last little bit there, we put so much energy into our Pipp horticultural products. A lot of it was to meet GMP standards, which really are directly tied to how do you reduce where debris can hide. We did antifungal microbial paint on all of our stuff. We've really made sure that the drainage and slope on everything that we do doesn't allow for sitting water. And so a lot of what we're talking about today has been backbone of our product development over the last 8 years at Pipp Horticulture. And so it's nice that I guess we're set up for success on that note. There's always going to be a little crevice and pocket, I'm sure, somewhere, but we've tried to address all the major concerns to make sure that our equipment meets GMP standards. So once we go indoors, you're like, okay, well, there's no animals and there's no less risk for migrational things coming from maybe neighboring farms. Greenhouses are a different animal because they do use a lot of passive air, but let's focus on indoor for just a minute. And let's talk about water systems and recirculation, because a lot of hydroponics is really based on water efficiency, but it's like one interconnected web. And with one interconnected web, depending on how the design is and what sanitation practices there can be inherent risk. So, like we talked about earlier, one of the biggest benefits is being able to frequently monitor, treat, and potentially recirculate water. A closed or highly monitored irrigation system can provide meaningful advantages. Operators may be able to better characterize their source water, install treatment systems, collect data, monitor performance, and respond more quickly when conditions change. However, recirculation also creates a trade-off. Danielle, can you explain why a closed loop or recirculating system should not be automatically described as safer?
The primary concern with recirculation or closed loop systems is that the water is shared throughout the production facility. So when contamination enters the system, it is possible for it to spread throughout rather than being able to be isolated or quarantined. CEA often uses recirculating systems, and so by that, where the water is filtered and treated, nutrients and oxygen are added, and then sent out to the plants for uptake before being captured and returning to the beginning of the cycle, which is great for water use efficiency, as you mentioned. But reservoirs, filters, piping, return lines, drains, your emitters, and the equipment coming into contact with that, such as channels and rafts, they all become part of a possible contamination pathway since they're being used in the distribution of that water. Validating and monitoring the water treatment process is vital, as effectiveness can be influenced by a lot of different things, from design conditions such as flow rate and contact time of your water through your water treatment processes, such as UV infiltration, to system limitations like organic matter being built up and creating a biological oxygen demand, or the equipment conditions, being able to stay on top of what your filter maintenance needs to be.
I find that a lot of people, operationally speaking, whether it's in CEA or in like cannabis specific CEA, they tend to overlook the importance of prevention. And a lot of the maintenance is reactive, and especially on new facilities. A lot of people have this mindset of like, oh, I just spent millions of dollars, everything's brand new. But that being said, like it is critically important to adhere to like a maintenance schedule. And prevention in our world is the difference between crop success and crop failure. In high dollar crops like cannabis, it can be not having a preventative program in place and really monitoring all this stuff like you're talking about. It can cost you hundreds of thousands of dollars, if not millions of dollars in crop loss. It's interesting, even with the Cyclospora stuff, like everyone, not everyone, I'm speaking generally, but a lot of people just said, oh, I'm not doing lettuce right now. I don't know what this is about, but that I don't have time for that. And it hurt several other farms that weren't impacted by this at all because the general population just wasn't educated on this. And so the immediate reaction for a lot of folks was like, I'll just avoid lettuce. Meanwhile, it was really like more of an acute, it impacted some farms and not others. One of the other things that comes up a lot for us when we're trying to track down disease and pathogens is really understanding and really trying to eliminate biofilm. So as we're talking about recirculating water, we're constantly trying to make sure that we reduce the amount of biofilm on some of these pipes and in our irrigation systems. But Danielle, can you talk a little bit about what biofilm is and why it matters so much in a CEA operation?
For sure. You're going to hear about biofilm a lot in the CEA and hydroponic context. It's just a fancy way of saying that it's a community of microorganisms that attaches to a surface. So once that's established, once a biofilm is established on a surface, it's much more difficult to remove than microorganisms just suspended in the water. They can develop in reservoirs and on channels, those sorts of surfaces, but big ones are the interior of pipes and in filters, fittings, emitters, basically all throughout your system where moisture and nutrients and organic matter all come together, which this is a biological system. And so biofilm is very easy to accumulate like all throughout a system, not just where your monitoring it and checking filters.
I know on the cannabis side, I like to use like dissolved oxygen with like a CIP feature that super saturates and essentially doesn't allow biofilm to produce. But I'm curious, what is like a common practice or preventative aspect for like leafy greens and stuff like that to reduce biofilm that you've seen be successful in the field?
A spin-off of the dissolved oxygen would be ozone, so O3 that gets converted to O2. When that happens, when the O3 breaks apart to be O2, it can eliminate biofilms. And then chlorine-based treatments as well, so ECA and other injected preventative measures.
Yeah, that makes good sense. One of the things that I ask people a lot, and I get this like confused look after I ask the question, is I go, "Have you validated your sanitation process?" And they're like, "What does that mean?" And I'm like, "Oh, well, let's talk about that because it's interesting. A lot of people will follow a protocol from could be a chemical product or something that's injected into the system, and there's this assumption that oh, well, it's supposed to do X, Y, and Z. And a lot of people overlook the validation process. And so I want to highlight that because it can avoid you a lot of headaches and troubleshooting down the road. But typically, if you have a sanitation process and you're like, our sanitation process is rock solid, great. You want to be swabbing before and after. You can use like a ATP machine. A lot of the local labs will come out and swab for you as well. And so I really encourage people cannabis or CEA to validate your sanitation practices or SOPs and make sure that it's actually doing what you think it's doing. And I find that when people actually go through that exercise, they have to make some adjustments to get to where they thought they were. So anyway, I just want to share a little bit. So in indoor and greenhouse CEA, we're obviously circulating a lot of water in some cases. So this is like a design issue, and you really got to make sure from a design standpoint that you don't have like dead legs in your irrigation where something might be sitting. You want to be looking at rough surfaces, seams, joints, undersides, hollow components, really anything that can increase like little microbial niches. Sometimes there's like almost like a P trap where I'll find that a lot of stuff gets sediment and things will get stuck to the bottom there. So from a design perspective, I think it's really important to be able to understand those issues and design a facility around that and mitigate some of that risk from a design standpoint. So at PIP, we frequently discuss how facility design affects productivity, labor efficiency, environmental uniformity, and scalability, but those same principles apply to food safety. So facility design can either support or undermine an operator's food safety program. And really the first question should be, can this facility and its equipment be effectively inspected, cleaned, maintained, and verified during normal production? I would say some important considerations to include is durable and cleanable materials, sufficient access around and underneath the equipment. It's what I really like about our mobile systems. If you have a fixed leg rolling bench and you're like, I'm going to clean under this, well, A, it's hard to do because you have to get down there. And I think there's probably a good amount of people that end up cutting corners a little bit there. And so with the mobile system, we're able to open up our mobile aisle and do deep cleans and then go to the next, open it all up, do deep cleans. We don't have to get underneath something per se because we're able to slide things around, which is really nice. Some other important considerations are effective floor and production system drainage. I know we spend a lot of time with customers. Drainage seems to be an afterthought. So we're constantly like advising and going off of best practices. I personally think you want a drain that's easily accessible. Sometimes they'll put them at the very back and they may have only inches to work with back there. And so it can make things harder to clean. And also when it's not in front of your face, sometimes it gets overlooked. I knew a really particular anal grower, and he was adamant about putting the trench drain in the front of the system. And he was like, no, I want to make sure that thing is meticulously clean because a drain can be a pathogen and disease pathway. We were able to talk him into setting it just a little bit further into the system so that he didn't have anything protruding out, which he understood from a tripping hazard and things like that. We really are trying to eliminate standing water. We're trying to control condensate. These condensate leaks above crops can cause problems. Typically, condensate is, in theory, like clean water, but it's typically high in pH and it's also high in microbials. And so, if you have a high microbial drip on a leafy green at some part of an indoor or even in a greenhouse setting, that can be where problems start. Making sure that you have access to your irrigation and return lines is really important. And as we talked about earlier, like delineating and separating clean and dirty activities and the tools that we use when we have those clean and dirty activities. So it sounds really silly, but like appropriate waste handling practices. I was at a facility that was dealing with botrytis, and I asked them how they were like, "Oh yeah, we're cutting it out and we're putting it into a tote, and then we're bringing it out." And I said, "Okay." I go, "Is that tote? Does it have a liner or a bag in it?" And they were like, "No." And I was like, "And you're just reusing that tote?" And they're like, "Yeah." And I go, "It has a lid?" And they're like, "Yeah." And I was like, "Well, I know that your intentions are good here, but you actually potentially could be spreading this more through your facility." Tighten up a few things there. But some other things to take into consideration is protection of the water in the growing media, access for equipment and maintenance, like we talked about, and then cleanable walls and floors and frames and trays and structural components. I think even in the greenhouse, we're seeing more like twin wall poly insulated acrylic, which is easy to wipe down, and foam. On the indoor side, we're seeing a lot of the IMP or insulated metal panels, which are really easy to clean. Sometimes people go on the indoor side, just, and I think it's maybe out of ignorance or maybe they think it's a budgetary thing, but they'll go with drywall. And drywall's like, I don't know, we say it's food for mold. And then maybe they'll put the FRP over it. So they're like, oh, this part's washable, but the FRP has seams. It's not always like perfect. And so it creates little nooks and crannies for disease and other microbiology to exist. So let's dive into your engineering background a little bit. So, from an engineering perspective, why is accessibility so important when developing a sanitation program?
It's important that a sanitation program is realistic and achievable and measurable. You want to make sure that the actions that you're doing are actually performing the way you expect, like you mentioned with validating your water treatment processes. We would try to reduce the number of surfaces that are inaccessible to people to be able to visually inspect, to clean and sanitize, and then also places where standing water can accumulate. So as you mentioned, we spend a lot of time working on making sure our trays drain evenly and fully drain. Those constantly wet surfaces can be dangerous for contamination. You would like things to be able to be easily disassembled if needed, to be able to clean in those nooks and crannies, or be able to remove entirely if you're not cleaning in place. And if parts of the system are just inaccessible physically to people, that makes all of those things a lot more difficult. So we take access either vertically or being able to move our racks as a very important design condition.
One of the things that I've been utilizing for years is biofoamers and biofoggers as well. So sometimes people, again, we talk about sanitation and being able to access things. Some people are like, oh, I pressure washed everything. And it's like, well, did you pressure wash it with city water? And also, how do you know what you actually hit from a contact standpoint? And there's really no sanitation with that. That's really just to get like debris and things like that. Maybe it's a good first step to get some debris together. But I find a lot of times on the indoor side, I've moved away from this concept of like putting water on the floor and pressure washing and all this stuff. And I've moved towards like HEPA filtered shop vacs for getting debris, and making sure that those are maintained appropriately. And then after that point, like a scrub down. Um, and when I'm trying to get all the nooks and crannies and surfaces, I love the biofoamer. The biofoamer gives me that visibility of like what, like I can see it, right? And it self dissolves depending on what products you're using, and it may or may not need a secondary rinse. And then lastly, we'll fog that space and just put it on a timer, put the fogger on, and do that overnight or something like that. And that multi-step sanitation process has really helped my teams and different projects we've worked on meet their sanitation goals. So now I want to talk a little bit about, I think it's really, the word might be discipline, but this is really about employees and operational discipline and really getting that buy-in from your teams where they're it's not about what Sally thinks is best or Billy thinks is best. It's like this is I'll just use Pipp. This is the Pipp way that we do this part of the work. Having that, a lot of people talk about SOPs, but when I monitor employee to employee performance based off of a written SOP, the deviations within each employee is significant. And so when we talk about operational discipline, people are like, oh, they were trained. And I go, when was that? And they're like, oh, when they started. Well, it's been a year or 2 years or 3 years, and all these, there's always drift. Like these things change. And so people drift away. But the thing is, people drift away in different directions. So I'm a big advocate for retraining regularly. And it's redundant. And you might be like, we know, but that's the point. You want to get to that point where it's so drilled in and it's so clearly understood of what the expectation is versus like, I was trained, but I forgot. So even with strong water treatments, quality equipment, and well-designed facility, the outcome ultimately depends on how like disciplined and consistent the people and the processes are. So the employees interact with crops, tools, water systems, growing media, containers. And I've said this a lot in person. I don't think I've said it on a podcast yet, but I'll say it here now. We are the vector. Like we in most situations, we're the ones that are people are like, oh, we got botrytis. And I'm like, but it's really the people, or we got powdery mildew, or we had pollination, or whatever it is. But it's like it's so critical to really educate your team on safe and clean handling practices because they're the ones that spread a lot of this stuff. So a strong program should address employee health and illness reporting, hand washing and glove practices, tool and equipment control, cleaning and sanitation responsibilities, production area traffic patterns, how people move and when they move. And if they were in a contaminated space that day, they should stay in that contaminated space or there needs to be a complete scrub down. And so sometimes if we know we have a room that's impacted by something that could spread, it might be the last room of the day. And then you go home. So there's little things you can do that don't cost any money. It just takes a little bit of organization and some discipline. So for Cyclospora specifically, employee health, hygiene, toilets, septic systems, and protection from human waste are particularly important because humans are the known host. Something that I've been educating my teams on the last few years, and we've even implemented some preventative equipment, is the contamination that's associated with your phone. When I first got involved in ag, it was like 90% of all your contaminations are going to come on the bottom of your feet, maybe on your hair or your clothes. And so that's why you see so many foot baths where people have work dedicated shoes and things like that. But as we've moved into this smartphone era where people are just on their phones all the time, and if you think about when people maybe sitting on the toilet, they might be browsing their phone. And so, how often are people sanitizing their phones? And unfortunately, not very much. And so, if you were to actually like look at like if you were to plate swab from your phone, you'd probably be disgusted. And so, what we've started to do, in addition to having foot baths and air showers and PPE, is we've actually been using these. We wall mount them in that general area and we can usually fit like I think 6 or 8 of phones in at a time, but we'll actually like UV and ozone cook the phones. And people love it. They're like, "Oh, my phone's clean." It's like it was an easy adoption for the teams that we've put that in place. So telling a team to keep the room clean and keep themselves, that's not an effective sanitation programs. Employees need to know exactly what must be cleaned, how it should be cleaned, and which product should be used. The correct concentration and contact time is really important. I did an exercise in California where I got to the greenhouse before everyone else got there on purpose. And I noticed the foot bath had been replenished the night before, which was great. And then we had 62 people come into a morning huddle. Two out of the 62 people actually stepped into the foot bath, and I was one of them. The other person stepped into it for not long enough to actually do anything effective. So again, sometimes we see some of this stuff in the field, but it's not effectively being used. And a lot of it's just lack of education. So I guess let's talk a little bit about some of the CYA components to this. Danielle, what role does documentation play beyond simply satisfying like an audit requirement for like a GMP audit or something like that?
Documentation, records, that all should be used to identify problems and then lead decision making. So good documentation allows the operators, the people on the ground, to detect patterns, identify recurring failures, like if you're seeing the same thing again and again, to be able to trace affected areas. So as you mentioned, of where did I go this day from room 1 to room 2? And then also to evaluate whether what they're doing, the systems in place are working. And as I mentioned, like all of this is to drive decision making. So for example, water results, sanitation, validation, environmental observations, maintenance records, all of these can help identify a problem before it becomes a larger problem. So it's not just for audits. These things should be used internally and should demonstrate that not only like something happened and activity occurred, but what did you use to mitigate it? And did that activity actually achieve the results you intended?
That makes total sense. I like what you said there because I look at it like a roadmap. Sometimes it's like you're trying to figure out what went wrong. And so if you have good documentation along the way, you can more easily identify what went wrong. But also when you crush a harvest, whether it's yield, quality, or hopefully both, it's also nice to have a roadmap of like, how do I repeat that, right? I had a really low microbial load on that crop. Like, what do we do differently? And so that's where I think documentation is pretty paramount. So I guess as we start to wrap this up, for operators listening today, I would prioritize these 5 areas. I'd first map the complete water system from its source to the point of use and when applicable through the recirculation and return system. Understanding where contamination could enter, accumulate, or spread is super important. It's probably smart to take water samples, whatever you're comfortable with, monthly or quarterly or annually at various stages of your water system so that you can maybe see if you do have something that's maybe impacting you, where is it coming into play? Second, I would evaluate whether the facility and the equipment can actually be cleaned, inspected, drained, serviced, and maintained. Pay particular close attention to continuously wetted surfaces, overhead condensate, drains, reusable components, any dead legs or inaccessible areas. Third, I would develop a sanitation procedure that clearly defines the cleaning method, cleaning chemistry, sanitizer, concentration, contact time, frequency, process documentation, and any corrective actions. And most importantly, once I had that sound, I would validate that process to make sure that I had it rock steady. Fourth, I would strengthen employee health. And a lot of that hygiene and training program, it's really through education and awareness. So these practices should be part of daily operations, not something activated only before or after an inspection or audit. And then lastly, I would monitor and document to make decisions. When a significant concern is identified, I would stop and investigate the root cause or RCA, identify the correct pathway, and verify that the corrective action was successful. Many times in operations, we see a lot of band-aid solutions, but the root cause was never truly addressed. And so it has a way of resurfacing itself. CEA gives growers more opportunities to control inputs, monitor conditions, isolate problems, and document activities, and respond to change in real time in some cases. But infrastructure and technology only provide value when they are paired with thoughtful facility design. Validated process, trained employees, and disciplined execution is key.
And in the case of Cyclospora, but specifically, but with other pathogens as well, the evidence really supports prevention-based approaches rather than relying on testing or washing the produce. As we mentioned, that is not considered an effective treatment for Cyclospora outbreaks. But in general, CEA can reduce the exposure to several of those external hazards that we've talked about, but biological risk still exists. Anywhere there are people and water and plants, it's a living biological system. And so it's important to remember that we need to do what we can to prevent these food safety issues.
Well said. Well, Danielle, thank you for helping us work through the biological and engineering side of this discussion. I enjoyed learning about some new stuff as we were preparing for this. So it was fun for me, and hopefully our listeners get some additional perspective on all this. And thank you for everyone who listened. We hope this conversation provides a useful framework for evaluating food safety as part of your facility design and everyday operating strategy.